Sitting back on the road, back on the road, and back on the road, back on the road. Steady as I go.
Hi folks, so thank you for stopping by. If you would like to learn how to build a camper van like this yourself, then please check out my other YouTube videos. So if you guys have found these videos helpful, you can help me out in a big way by picking up a copy of my first ever album that my brother and I recorded in Nashville late last year. Any proceeds will go to future recording projects, as well as taking the band on tour and hopefully promoting it. I'll leave a link in the description and talk a little bit more about it at the end of this video. Okay folks, so welcome to this video about our first fixing for our electrics. So the difference between our first fixing and our second fixing is the first fixing is basically we're going to be feeding all our wiring through, and the second fixing would then actually be fixing them up to our 12 volt appliances, power management unit, fuses, battery, etc. So our first fix is basically just getting the groundwork done. So first of all, I'll tell you what the electrical system normally consists of inside a camper van or RV, depending where you're from. So we normally have a leisure battery, and it'll most likely be 12 volt. That's what a lot of systems use on camper vans, motorhomes, things like that. You can use more than one leisure battery as well. You can have multiple if you want to boost your battery supply. You'll have 12 volt appliances. You'll have things like your fridge, lights, light switches, water pump, water heater, USB sockets, 12 volt sockets, and your toilet can also have a 12 volt flush on it. You'll have 230 volt mains appliances, including sockets. So you might want to put a couple of sockets on. You might have things like a microwave or toaster, though the mains appliances tend to take up a lot of power if you're wild camping, but they can be useful if you're at campsites. So those are sort of the appliances. Just basically take out whichever ones you want. That's the beauty of making your own camper van, is you can just take what you need and install it. So also inside the electrical system, we're going to need to fuse all of the cables. For our 12 volt system, we'll have fuses. So fuses will basically burn out if that circuit is being overloaded. And for the 230 volt, the mains power, you'll have circuit breakers, so they will just flick off, and you will be able to flick them back up once you've sorted out the problem if there was one. So you'll also probably have a charging system of some sort. Be pretty mental not to. So you'd probably have something like a split charge relay, for example, and the point of that is to charge the 12 volt leisure battery whilst the vehicle is running. You could have a solar panel as well that could also charge your leisure battery, or a wind turbine if you want to be sort of self-sufficient. Those are a couple of options, and you'll probably have a mains inlet which will allow you to hook up at a campsite, and when you're hooked up, that will also charge your leisure battery for you. You may also want to install an inverter. It's totally up to you. What it basically will do is bump up the 12 volt power to 230 volts, so you can run all your mains system whilst you're not on a campsite. So whilst you're wild camping, you can basically use all of your mains plug sockets. That's what an inverter does. Without that, you only be able to use your mains plug sockets when you're at a campsite and you're hooked up. So what we're actually going to go ahead and wire up during this first fixing, we're going to run all our cables behind the walls, and that's all the cables that are going to be going to any of your 12 volt appliances, so any of the cables that you're going to need for your lights, your fridge, whatever it is, and any of your 230 volt plug sockets as well. You need to run the cables through those behind the walls now before we start putting the walls through, so they're covered. Of course, you don't have to do that. You can leave them exposed, it just looks tidier not to. You also need to begin feeding any wires through for your split charge relay if you decide to use one. We're going to feature that in a separate video on how to install one of those, so please have a look at that if you're going to go ahead and do that. And we're going to mount the mains in that. You don't have to do that right now, but it just makes it easier to know where it is. So with the 12 volt power then, feel free to pause this video on any of these pages so that you can have a little read through. For the 12 volt power then, like I said, we're going to have a 12 volt leisure battery, and you can have more than one connected together if you want to boost your power storage. And power capacity will be measured in amp hours. So to work out, I'm just going to read this off, to work which size battery you need, you must work out your power consumption in amp hours. So all batteries are rated in amp hours, and it can vary greatly. Some can go as far as, I think, about 220 amp hours, which is pretty big. So to work out how many amp hours you're going to need, how big a battery you're going to need, you're going to need to work out what your appliances, so your 12-volt appliances, your fridge and your light and everything, how much power they're actually going to draw, to know how big a battery you're going to need to sustain enough power to power all of those outlets over the course of a day, or until you next find a power source. So you can usually find the amp hour information on the manufacturer's or the seller's website or on the product box, but if it only gives you the power consumption in watts, you can work out the amps by taking the wattage and dividing your voltage, which in nearly all cases will be 12, as we run 12-volt systems. So for example, if we had a 60-watt appliance, say maybe that was a fridge, say we couldn't find the amp hours on the fridge and it just said 60 watts on the box, you take that 60, you divide it by 12, which is our voltage, and that will tell you how many amps that your fridge is going to draw. So 60 divided by 12 will give us 5 amps. If it was a light drawing 2.4 watts, divided by 12, it would have an amp rating of 0.2 amps. So you get the idea. You then need to times the amp rating by the amount of hours you think you would use that appliance each day to give you the amp hours. So far we've just worked out how many amps it is. To work out the amp hours, which is how they rate batteries, you would then need to go and work out how many hours you're going to be using your appliances for. So if we take our light, for example, say we used it for 5 hours a day, bearing in mind that you will be using things like that more in winter, so do allow extra hours for those winter hours when it's dark, then we would do 0.2, which is the amp rating, times that by 5, which is the amount of hours used, which would give us 1.0, meaning it would use 1.0 amp hours a day. So you can go ahead and calculate that for every appliance that you have, and I'd say be generous to ensure that you've allowed enough room for them all to work, and then add all of those calculations together, and that will give you a rough idea of how many amp hours you need your battery to hold. But don't forget that some leisure batteries can only drop to 50% charged before they need topping up again, otherwise they will suffer damage. So for example, if we needed 40 amp hours a day, you would at least need an 80 amp leisure battery. So you'll need to check on your battery if it has a deep cycle ability or not, because some of them can only charge can only go down to 50% charge. If you go any lower than that, it will damage the battery. So using this will also help you decide if you need to use a solar panel or not as well. Keep a note of those amp ratings as well for each appliance, as it will be useful later for determining the cable / fuse sizes. When you're buying your battery, just check as well whether it's maintenance free. Gel and AGM batteries tend to be, and again, like I say, check if it has a deep cycle ability. If you want more information on all things to do with batteries, if that sounds fun to you, and any maintenance advice, come and check out this website, and I'll put a link in the video as well. Cool, so one of the first things we're going to do with the electrics is I'm going to roughly put things in place. My leisure battery there, my power management unit, and then I'm going to mark out where I want all the wires to go. So I've got a couple of LED lights, for example, which I've marked out here, and as you can see they're going to be heading up here and around here. So the first one's going to be there, and the first one's further down there, and I've measured the distance between these two parts as 70 centimeters, so I found the middle area of 35 centimeters, so it looks nice and central when I go to put that light in. I made a cross there. So before I feed all the wires through, I want to put some conduit through. Some of this plastic conduit. This one's 20mm thick, which will be plenty to get my wires through. And because my insulation is going to be flush with these panels here, I actually want the conduit to sit behind these panels so that it doesn't then protrude and then stop the cladding from being able to be laid in front of it. So I've cut a hole here already as an example. What we're going to do is, once we've cut this hole, we're going to put some of that red oxide around it just to protect it, and then put a rubber grommet in it, which is then going to protect the conduit. The hole I've cut there is 25mm thick. These are 25mm rubber grommets, and that will just about fit the 20mm conduit through. I probably would have gone with something slightly bigger next time, but as you can see, I don't have a lot of room on my panels. You probably will on your van. But if you've already got holes in your van, it's a good point to make that, you know, there's no point making any others if you can feed it through something else that's already existing. Fortunately, this van doesn't really have many options. But so first, what I'm going to do then, cut some holes out and I'll show you how that's done. Cool, so just to quickly show you my hole saw piece then. This bit here is called your hole saw, and this bit is called an arbor if you need to buy any of these from Screwfix or anything like that. So this one's 25mm thick. It simply just screws onto the arbor there and then you just whack it into your drill. I've got my hole saw piece on. I've got my mark there. I'm going to place the pilot bit of the drill on top where I want it. Then I'm going to make sure I'm using both hands when I'm drilling this part out. Put a little bit of pressure on the top and then just begin to drill. You feel it drop like that. When you get to this point you need to be careful with your wrist because the drill will tend to flick about a lot. This isn't the correct drill to use really for the job, so just take it steady and make sure that it's well supported. Cool, so next up we're going to file these edges. Want this to be nice and smooth, and then once we've done all this we want to take all the debris here and we want to hoover that up, otherwise that's going to rust. So next we're going to cut the hole for our mains inlet. So to do this we need to make sure we've got the correct blade. I'm using some T218A Bosch jigsaw blades, which are good for cutting thin sheet metal. These are called T-shank blades. You can also get ones I believe are called U-shank, but I have a T-shank jigsaw, so you need to check which type of jigsaw you have to know which type of blades to get. So to change the blade, all you simply need to do is twist this, the blade will pop out. To pop it back in you need to make sure the teeth are facing out this way, and then you pop it back into place and then you turn it like that. Make sure though that your jigsaw is unplugged. This is what our mains inlet looks like. It's going to be connected up to this orange cable in the power management unit. And so what I've done to start things off with is I've placed it here, making sure it's going to be within the area that the power management unit is going to be in. This orange cable will eventually connect up to it and it'll obviously be facing out that way by the time it's actually glued to the side of the van. I've drawn around it with a big felt tip. I'm going to put a pilot hole in it and then go around to the other side and outline it again with a felt tip and then use that outline to then cut it. So I've got the biggest metal drill bit that I've got, so that I can later fit my jigsaw blade in. I'm then going to put it up in this top corner here and then cool, so now we line it up with the pilot hole in the same place. I'm going to draw around it with a felt tip. Cool, so make sure it's all straight and then we can start drilling. There's two more things before we drill. I've covered the base with masking tape just so that I don't scratch any of the paintwork off of the van, and I've also got my glasses on. Just take it steady when you do this and just follow the outline. Cool, so I'm just going to check it fits, which it does nice and comfortably. I'm just going to go around the edges now with the file and then we'll get the red oxide on all these holes we've made. Give this a good stir and then apply it all around the bare metal edges. Being careful not to drip it down your paint. Cool, now we've given our red oxide some time to dry, we're going to put some rubber grommets in. There's one done here already. There's a little bit of red oxide showing on the sides, which is absolutely fine because it's going to be behind some cladding anyway. But you want to be careful around your mains inlet. Cool, now our red oxide's all dried, I'm going to put the mains inlet into place. Making sure that it's nice and straight. I'm going to take a pen, and there's in each corner there's a hole for the screws to go in. And what I'm going to do is I'm just going to put a pin mark under each one. Seal those what you can, and I'm going to be
using some of these screws. I'm going to use a drill bit that's designed to drill into metal. This drill bit's going to be slightly smaller than the screw, so the screw's got something to bite onto basically. Cool, screws are in place. There we go, and then connect out later.
So I'm just going to quickly touch on how to identify the correct size cable and fuses needed in your electrical system. Now it's really important that you always pick a cable size that is above the current draw that the appliance needs. Now if you go too large, that isn't going to do any harm at all. It's just going to cost you a little bit more money to obviously buy the bigger cable. But if you go too small, that is when we're going to start having problems, as that's going to generate heat in the cable. So say if we had a 10 amp appliance and you used a 5 amp cable, that's going to generate a fair bit of heat and will lead to problems. So cables are sized in a few different ways, and you may see it measured out in amps, and if you do, that makes it really easy to choose the correct cable size. All you need to simply do is check the amp rating of the appliance, and then I would add an extra 25% to that amp rating for safe practice, and that will give you the amp rating that you will need for your cable. So say for example our light draws 0.2 amps, which after we've added the 25% would give us 0.25 amps. That would mean that we could use a 5 amp cable quite happily. They don't really get much smaller than 5 amp, that's why we've gone so much higher. But yeah, if we take our fridge as another example, which would draw 5 amps, and then we add that extra 25% again, that would mean that it's going to draw safely 6.25 amps through a cable. That would mean that using 5 amp cable would then be too small, because it's 6.25 amps, obviously over the 5 amp limit. So we'd be looking for the next size above 6.25 amps, which might jump up a bit, and you'll probably find it might be something like an 11 amp cable. And we can determine the fuse size in a similar way. So they're often rated at 5, 10, 15, 20 amps, something like that. So again, you just literally take the amp rating of your appliance and you would add the 25% and go for the next fuse up. So say a fridge, for example, that would use a 10 amp fuse, and our lights would use a 5 amp fuse. Cables come in different sizes, and they tend to leap from one amp rating to another. They can also be measured in millimeters squared or AWG. So here's a few conversions in case you're looking to buy this online, and they have got it in a couple of different ways. So feel free to pause on this and just take note of that. You can also Google it online and it will tell you if you've got some other weird denominator that you need to work out. An extra point to make is that cables will cause a voltage drop, especially if they run for a long distance. So the voltage will literally drop the longer the cable goes on, as the current makes its way through. So allowing for a larger cable will also help to counteract this. And you can work out your voltage drop and find out if you need to use a larger cable or not by using a voltage drop calculator. And I've put a link here to a website which has got a really good voltage drop calculator, and they've got tons of really helpful information on there as well, all about cable sizes and what to use, etc. So it's definitely worth reading that. Cables used for campers are made out of multiple strands as opposed to a solid core, which could become brittle with the van's vibrations and break down. So multi-stranded cable is far more flexible and it can withstand the vibration. So it's really, really important that you always get the multi-strand flexible cable for everything that you wire up inside your camper van. For your 230 volt mains outlets, ensure you have flexible 3-core cable throughout. So 3-core meaning that it will have 3 different cables, so that'll be your earth, your neutral and your live. The household cable that you would normally use is too brittle, and again it won't withstand the impact of the vibration, so make sure again that it's flexible cable. And all 230 volt cables need to be run through circuit breakers as opposed to fuses. So like I said before, fuses will melt away, circuit breakers will just flick off and then you can flick them back on. There can be a tendency to have a bit more of a surge in power with mains voltage, so that's why they tend not to use fuses and use circuit breakers instead, because they will flick off more often than fuses will. So it'll be easier for maintenance reasons to just be able to flick it back on. You may have circuit breakers included in your power management unit, but if not, like the one we're using, the EC160 power management unit, it has a 16 amp input and the miniature circuit breakers are rated at 10 amps. So I think that'll give you over 2,000 watts of power to play with on each power socket, so that's plenty.
So as you can see, I've started putting the conduit through. I'm going to leave a little bit of excess here where it's coming out of the power management unit, just to make sure that these cables are protected all the way to the edges. So I've simply fed it through the rubber grommets now, following the lines that I drew out on the van, and it's ended up just up here where the 12 volt light's going to be. It should end perfectly there where the light should end. So yeah, just a case of pulling it all through. Now, one thing I would say is I've got 20mm conduit here with a 25mm rubber grommet. I think in retrospect it would have been better to have had a slightly bigger grommet, because as you can see when I pull this through, it's a little bit stiff, so give yourself plenty of room to make this job a bit easier. So for the longer bit of conduit that's going to be running all the way up and around here in some fairly tight little corners, I'm actually going to run the cabling through the conduit before I put the conduit through. With these other ones, as you can see, I've pulled wires through those. They're going to be the draw wires, so I'll attach whichever wires I'm going to be using later on and just pull them through the other end using this one. I'll just tie it onto the end and pull it through. So yeah, we're going to get these ones through first. Just folded the ends over on these smaller wires just to make it easier to push through, and we're also going to put the 3-core mains cable through. So we've just cut off the ends with our wire cutters, making sure we're leaving enough excess here to reach our plugs and the power management unit later on. And we're just going to tie these off as well, just to make sure that they don't get pulled back through the conduit later. Just like that. Now there's no chance of it going back through the conduit. So just to recap then, we've cut the holes for the conduit. We've then filed them off to make them nice and smooth around the edges. We put red oxide around those, just to make sure the bare metal doesn't rust. Then we put rubber grommets around those holes to protect the conduit as we fed it through. Then we fed the conduit through following all the lines that I had drawn, entering from where the power management unit is going to be, so basically where your fuses are, and then ending where each light is going to join up. And then I fed the wire through the largest one that I thought would be difficult to draw through later, and through the other pieces of conduit I've fed these wires through by bending the edges like this and then pushing it through, and then we're going to now glue it all onto the ceilings using a glue gun. So I'll show you this next. After we've applied the glue, we're just going to hold it there for a bit in place, just to give it time to set. I'm just going to follow that all the way around. Cool, so all the conduit's in and it's all glued in place now, and this is what it looks like. All those bits there, it's a bit untidy down there, that's where it's all going to come out at the end. Being such a small van, all my electrics are pretty simple. So this one I've already got my mains cable here and the positive and negative to go towards my USB. So I don't have to worry about feeding those wires through, but I'm just going to feed some wires through here. So I've got the draw wire coming out already, which I fed through earlier. Again, like I said, if you fold the ends over, it's easier to push it through the conduit. And then what we can do is we can take the positive and negative that I need here, and we'll tie it to the end, and then we'll just pull it through the other side and it will bring it through. There we go. Now I can just untie this and release this wire, which is our draw wire. Then what you want to do, if you've got any excess cable, is just trim off the ends, but make sure that you're leaving plenty of excess so that it will reach your fuse box and it will reach whichever power source you're taking this to. And then we're just going to tie off the ends just to make sure that they don't accidentally get pulled through at a later date. You can also label each of these as well. If you've got loads of electrics going on, it's a good idea to just label the end of the conduit or the wires just so you know what's going where.
Cool, so I've just added some masking tape to the ends of the wires and then written the place that they're ending up, just so I know, which is a bit comical really on this van because I've only got about 4 wires coming out of it. But if you've got you know, a much bigger system, which you probably will, then it's really handy to do this straight away after you've wired these. Cool, so as far as electrics go, we're all done now. So that's the first fix all completed, which is just, you know, sending all those wires through, and now we can put the insulation and build around all of these, and then later on towards the very end we'll connect all these together. Cool, so I'm quickly going to explain the wires that I've used and why I've used them. So for the 230 volt, which is our mains plug, I've used this is called an Arctic Fox, this particular cable. It's a flexible 3-core, it's called 3-core because you've got 3 different types of wires. This needs to be flexible, so make sure you don't use normal household cable because it will be very stiff and it won't deal with the vibrations of the van. It will become very brittle and it will break over time, so make sure it's flexible. This is a 16 amp, this is rated to, so 16 amp is around about, I think it was 3,680 watts that we're allowed to pass through this wire safely. So there's little circuit breakers coming off of my power management unit which are rated to 10 amps, so they will flick if anything over 2,300 watts is being pulled through it. So this will handle that, as it can handle up to 3,600 watts. So basically you don't want to be plugging in anything really heavy duty, you know. You can get a microwave in there and things like that, that's okay. So all I've done is you just need one of these cables. Unlike our 12 volt systems, we've got a positive and negative. We've literally just got one wire running through, and I'm running that from your circuit breaker or your power management unit, whichever you're deciding to use. Your power management unit will have a circuit breaker in there. You're just going to send that from your circuit breaker / power management unit, and you're going to run the cable to wherever your socket is, okay? And my socket's sending up here. And that's basically it for your 230 volts, okay? For things like my USB sockets, for example, we're literally just taking a positive and negative. I bought red and black wire so I can easily differentiate between what's positive and what's negative, okay? This particular cable here, this was rated at 8.75 amps, I think. So my USB socket, when I looked up how many amps it would use, it was up to, I think, 3.1 amps was the maximum that would pass through it. So using an 8.75 cable is going to be plenty to handle that type of power that's running through it. So they're very small cables actually. I would have used 5 amp, but they didn't have 5 amp in the store, so I just used the nearest thing that was up from that. So when you're trying to work out which cable to use, don't forget, say for example it's 3.1 amps, which is the power draw for my USB sockets, add an extra sort of 25%, so say it's going to be around about 4 amps of power that it's going to draw. 5 amp cable will safely draw the amount of electricity through it, okay? So it doesn't do you any harm to use bigger cables. It will do harm to use smaller cables, okay? So using anything smaller than 5 amp, I don't even know that exists, to be honest. But what will happen is it will heat up, it will get really warm, and it will end up melting the insulation, and then you're going to get breaks. That's when you can start causing fires and things like that. So always go for bigger cables than your power outlet is going to draw, okay? So for example, my 12 volt socket, this is a good example actually. So the maximum that will draw is 5 amps, so I wouldn't want to get a 5 amp cable for it because I need to add that additional 25%, which would be what, 1.25, so I need something that's at least 6.25 amps. I think this one actually I went up to, I think it was something like 17 amps for this cable. That's what they had in the store. So that, again, that's just a positive and negative running to the 12 volt socket, just a positive and negative to the USB sockets. For the lights it's slightly differently because we've obviously got to connect up a couple of lights, so I'm doing this in parallel, which means if I do it in parallel rather than a series circuit, it's 2 different types of circuits. Parallel will allow the other lights to work when one of them breaks. So say the bulb goes, instead of in a series circuit where all the lights will then go out, in a parallel circuit your other lights will still be able to work even when one of the bulbs goes on the other lights. So I'll quickly put together what a parallel circuit would look like in comparison. So essentially, every light has its own little circuit. Instead of it all just going around one big loop like it would in a series circuit, in a parallel circuit, there's sort of a mini circuit going to every single light, and therefore if one of these lights were to go, electricity could still flow to the next light, and so on, and everything else would be able to operate apart from that one light that's blown. So essentially the difference then between a parallel and a series circuit, as we're piecing it together, is that in a series circuit we would just have one wire going into the positive and then one wire coming out just from the negative. And then in the parallel circuit that we are using, there's going to be one wire coming in from the positive and then also coming back out from the positive. Same with the negative, one wire coming into the negative and one wire also coming out of the negative. So you would essentially do this all the way along to all of your lights, so I'm sure you'll have more than two, and when you get to the very end there'll just be one wire coming into the positive and one wire coming into the negative, and that will complete your whole loop. So all I've done here is I've run a positive and negative. Again, this is 8.75 amp cable. You can use 5 because we're only drawing, I think it was 0.16 amps between each light. And we're just running a positive and negative all the way up here. Coming out at our lights, make sure you leave plenty of excess on each end to get to each point. You can cut it down later on. And what we're going to do later on, there's a positive and negative then going to the next light, which is going to be here. So what basically happens when I go and crimp these up later is there'll be a positive and negative coming off my light. So I'll take the positive that's coming off the light and I will crimp, which is basically the type of connection we're going to be doing. I will connect both the positive wires to the one positive cable on the light on this side, and again with the two negative cables we will connect both the two negative cables to the one negative cable coming off the light here. And then when we get to that end, because it's the last light, we're just going to crimp one positive cable onto the one positive cable on the light, and the negative cable here will crimp to the one negative cable coming off the light. So if you've got more lights, then you're going to need to put one positive coming into the light, one positive coming out, one negative coming in, one negative coming out, until you get to the very end. Thanks for stopping by, everybody. Please like and subscribe and check out our other content on all things camper. As I mentioned before, I've just recorded my first album and need all the help I can get, so I'll leave you with an album preview for now and a link in the description if you'd like to pick up a copy.
She does all that she can. Yes, anymore. Time, I'm heading west, yeah, till I cross the $6 short, but my soul is clean. I need one more dime. The fruit machine swirling waves on me. Yeah. You put their cold and harsh demeanor, it'll soon come back around. So don't let the bastards get you.